Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're looking at 3.6. This is all about graphing trigonometric equations. The last video we kind of did the reverse. We looked at the graphs and we created the functions. So these ideas should be very similar. If you are lost on some of the things I might be talking about, you might want to go ahead and watch 3.4 and 3.5 to get caught up. One thing useful that we're going to be looking at, again, is our transformation form of our sine and cosine graph. I will give the form for sine here. Remember what each of these different components mean. We know K is the midline. It's the vertical transformation or translation. We know A is the amplitude. It's a bad arrow. We know B. Remember, B is equal to 2 pi over the period. And your horizontal translation. No specific words. You can call that a phase shift if you would like. Translation. Okay, H is your phase shift, but again, that is just the horizontal translation. And we only really find that or apply that in specific cases because these functions can be made just by repeating themselves. So you don't always apply a horizontal translation. Let's go ahead. Let's start breaking this down. So what we want to do is just sort of graph this. You want to make an appropriate scale. So really what we care about is how long does it take for a cycle to repeat? Well, we want to know what is the period then. Well, we can find period by taking 2 pi and dividing it by the b value. Our b value in this case is 5. So we know this is a sine graph. It'll start at the midline, it'll go up, it'll go down, and return to its spot. That entire time it takes to do that will be 2 pi fifths. Whenever you have sine and cosine, one thing is always true. If I have sine, it starts at the midline, it repeats its cycle in one period, but it gets half of that distance or returns to the midline half of its period. That means it gets to its maximum in a quarter of its period, or it gets to the minimum at 3/4 of the period. So what I can do to kind of cheat this whenever I graph it is I can make the period just kind of 4 tick marks on our x-axis. So I'm going to say that our graph gets to right here. We're going to call this 2 pi fifths. That is our period. And here's the reason. We know this is a sine function. It starts at the midline. Notice there is no k value, so our midline is 0. So it starts at 0. We know the amplitude is 8 units. So that means my graph will go 8 units high and 8 units low from that spot. So maybe you count up 4, 8, that would be up here. Well, in order to get to the 2 pi fifths, my cycle is going to occur. So from the midline, it goes up. And at 1/4 of the period, it reaches its maximum. Well, 1/4 of its period was 4 tick marks, so 1/4 of that would be right there. We know that at half of its period, it returns to the middle, the midline. We know at 3/4 of its 3/4 of its period, it goes all the way down to its minimum, which is right here at -8, before it returns to the midline at 2 pi fifths. We've just graphed it. Yes, it's just by graphing 4 points, but that's really all you need. We know our function is a curve, though. This will be kind of hard to do. I'm going to shrink these down so it's easier to draw. I'm going to make this 4. I'm going to make that 8 right there. And I'm going to shrink this down to also just be 4 units. Do you have to do this? No, but it just makes it a lot easier for me to draw on a laptop for this. So now we can see it does that. Remember, it's a wave though. It will just continue to do that same thing. So if you wanted to graph more than one period, you could. And it would just continue to do that exact same cycle over and over and over again. Okay? Realize in order for it to go to the next period, it would be another 2 pi fifths. So you would just add 2 pi fifths and 2 pi fifths. So 2 periods was done in 4 pi fifths. And we could start to find each of those different period amounts and label more things on the y-axis. That is the basic idea of how to graph this. Let's look at another example with cosine this time. Remember, cosine starts at the top, goes down, and then returns to where it was. Let's find our different values. We need the period. The period can be found by taking 2 pi over b, which is, again, 2 pi fifths in this case. It's okay if they're the same. We know that it needs to hit 4 kind of check marks in order to complete its period. So I'm going to go to the 4th dash here. Call that 2 pi fifths again. We know our graph is shifted up 6 units. I'm going to scale it the same as I ended with on the last one. So each y value will be 2 units. So I'm going to get to 6 right here. But I also know the amplitude from there is also another 6 units. So that means I need to get up to 12 and I need to get down to 0. Okay, here's our midline. We know this is a cosine function, so it must start at the top. So it's going to start way up here at 12, and it will still go through each of those checkpoints. If it starts at the top, the next spot it would get to is the midline at a quarter of its time. It would then go to its minimum at half of its period. It would return to the midline at 3/4 of its period, and then it would return to its starting point. It would complete a cycle at its full period length. Again, it's a wave, so try and draw it as one. And then it could continue to just repeat that same cycle, giving us something that looks like this. You see the wave function starting to form. You could continue to label other values along the x-axis if you would like. Again, just double the amount or triple the amount to continue making those labels. So 4 pi fifths times 2, or sorry, 2 pi fifths times 2 would be 4 pi fifths. It would repeat another period at 6 pi fifths, and so forth. That is our video for 3.6, graphing trigonometric equations, focusing on sine and cosine. Thanks for watching.